Good afternoon. My name is Steve Boyd. I'm the Director of Research at the Irving Institute for Energy and Society at Dartmouth College. Thank you for the kickoff of our series this winter term here at Dartmouth College, where the theme this term is critical infrastructure in a climate changing world. And this is the first session titled Vulnerable Systems, Climate Urgency, and Energy Equity. And again, thank you for joining us. You will see a Q&A down the bottom of the Zoom screen where you can ask questions during the course of the two talks you're going to hear. The first by Erich Osterberg from Dartmouth College, and the second by Shalanda Baker from Northeastern University. And please ask questions as we go along, but we'll have a Q&A at the end, so we can just get through the talks first and you can hear the full extent of the presentations. I'm very excited about this kickoff today because Erich comes from the climate side of things. He's an associate professor in earth sciences at Dartmouth College, has been here since 2007, and his research really focuses on climate and understanding how and why climate has changed, identifying trends and sources of pollution. His specialty is really looking at very long-term records, 50 to 50,000 years, by looking at the isotopic element mix and other markers that allow you to understand what happened to climate. And that allows him to disentangle what's being caused by human presence versus the natural cycles of what happened in the Earth as it evolves over time. And so he's going to give us a nice picture of sort of from the climate science side of things. And then Shalanda's specialty is really to look at the impacts around, and this is really from a sort of energy justice, equity perspective. How are these climate changes going to manifest themselves for people? And so when we say infrastructure in a climate changing world, and we say vulnerable systems, we don't just mean the actual nuts and bolts of materials and bridges and things like that, but also people. Shalanda is a professor of law and public policy and urban affairs at Northeastern University. Before joining there, she was at the William S. Richardson Law School in Hawaii. She has spent over a decade conducting research on the equity dimensions of the global transition away from fossil fuel energy to cleaner energy sources. She is also a co-founder and co-director of the Initiative for Energy Justice, and an organization committed to providing technical law and policy support to communities on the front lines of climate change. Interestingly, too, her book, I think, has just come out, called Revolutionary Power, An Activist Guide to Energy Transitions. And she argues that energy policy should be the next domain to advance civil rights. So it's going to be a really interesting combination today. And without further ado, unless you want to add anything, Stephanie, please kick things off, Erich.
All right, thank you very much for that introduction, Stephen. So I'm going to share my screen with you all and start my presentation here. So as Stephen said, my intention here is to really give you the climate urgency side of this equation, and then Shalanda is going to be talking about the energy equity side of things. And so to start with, I'm going to show you a graph that many of you are perhaps familiar with. This is a graph showing how the average temperature of the globe has changed over the last 140 years. And so you've got 140 years ago, 1880 on the left, and you've got today on the right, and we can clearly see climate change. We can see global warming. We can see that the Earth has warmed by about 2 degrees Fahrenheit over the last century or so. And it's really rising fast. And what I'm showing you here is actually just the data up until 2014. And I want to do that to really emphasize just how dramatic the warming has been in the last 5 years. So here's the rest of the data, which is 2015, when we saw a new jump of the record warmest year, and then 2016, which is that top one there, which was another huge jump to a record year. Previously, you know, the new records would just be sort of fractions of a degree above the previous record, but 2015 was truly shocking to the climate community. And then 2016 was even more dramatic. And I don't know if you've heard, but in the last couple of days, it's been announced that 2020 was tied for #1 warmest year, along with that top peak 2016 there. And one point I want to make absolutely crystal clear is that since about 1960, all of the warming that we've seen is from human activities. Okay, all of it. And not, the evidence suggests and we believe, blah, blah, blah. Like, we know that 100% of the warming that we've seen since 1960 is from human activities. I want to make that unequivocally clear to you. And the reason that we know this is because there actually aren't all that many things that warm the entire surface of the planet like this. We know that greenhouse gases is one of them, especially CO2. And the other two that could change the surface of the planet naturally would be either volcanic eruptions, which tend to cool the planet. So if you have fewer volcanic eruptions, you could warm it, or the strength of the sun. And I know we think about the sun as sort of this persistent ball of energy in the sky, but it actually gets stronger and weaker through time. And so what I'm showing in the bottom plot in black here is that same time period back to 1880. And I'm showing that same temperature record at the top, but in black is the change in the strength of the sun. And you can see these big cycles, and that actually represents the 11-year sunspot cycle. And so if we smooth out those sunspot cycles with that darker line, what you can see is that the sun got a little bit brighter going up from the beginning of the century to around 1955 or so. But since around 1960, the sun has been getting weaker and weaker and weaker at the same time that we've seen these record warm temperatures at an extremely fast rate. And so the sun is actually so weak right now that NASA has declared this a grand solar minimum, which we have not seen since the 1800s during a time that we call the Little Ice Age, when it was about a degree colder than it was in 1950, and glaciers around the world were actually expanding. Okay, so this weaker solar radiation should be making us colder. And yet we are overcoming that cooling, that natural cooling, to give us this dramatic warming. And so let's focus in on the CO2, because that is really the story here. I want to emphasize just how unusual this change in CO2 is, both in terms of the level of CO2 we have now, which is 415. The units don't really matter, but also the speed at which CO2 has increased. So what I'm showing here is an ice core record of CO2 in blue and temperature in red, going back much longer now. So here we're going back 800,000 years. So that's 800,000 years ago on the left and today on the right. And what you can see again are these cycles. And these cycles represent the Ice Age cycles. And I know some of us think about the Ice Age, but it turns out that there were actually lots and lots and lots of Ice Ages. So every time the temperatures were low here was an Ice Age, accompanied with low CO2. And so we can see this really close parallel between CO2 in the atmosphere and temperatures. And this is true over 800,000 years. And it's actually true anywhere we look in geological history, going back millions and millions of years. When CO2 is high, it's warmer. When CO2 is low, it's cooler. And this makes perfect sense because of the physics of how CO2 traps heat on the Earth. So the last time that the Earth was at this level of 415 was actually at least 3 million years ago. We can see that naturally with these Ice Age cycles, it ranges from around 180 up to 280. And so this 415 is completely unusual. And to give you a little context for that, our species first evolved on this planet only 300 to 400,000 years ago, right? So our species has never seen CO2 of this level or experienced a rate of change of CO2 this fast. So I know that some of these CO2 changes as you warm up coming out of an ice age, like this one here about 15,000 years ago, these look really fast. But the rate of CO2 increase that we're seeing now is 150 times faster than even these fastest changes in CO2. So this change here, 15,000 years ago, coming out of the last ice age, was an increase of 80 units of CO2 over 6,000 years. And in my lifetime, in 43 years, we have seen that exact same amount of CO2 rise. So 80 in 43 years versus 80 in 6,000 years. So this is an experiment that has never been run before, as far as we can tell, in geological history. The Earth has never done this before at this rate. And the evidence of what is happening is just all around us. Okay, so this past year we had record wildfires, first down in Australia, and then in California, and then in Colorado. And we know that this is associated with higher temperatures and changes in rainfall, which make these more likely to happen. Even up in the Arctic, Above the Arctic Circle in Siberia, we had temperatures above 100 degrees this summer, and we had, again, record wildfires. I follow the hurricanes very closely. I'm a climatologist and a meteorologist, and I study and follow hurricanes. And this past hurricane season was frankly crazy. Okay, it was a record hurricane season. We had never seen so many named storms. As you may know, we ran out of letters. We had to go into the Greek alphabet. That happened once before in 2005, but we had even more storms this year than we did in 2005. And again, research proves that the warming of the oceans and the warming of the atmosphere is making these hurricanes more powerful than they used to be. So it's not just that we have more storms than we used to. It's that the storms that form become more powerful. I don't know if you noticed, but you might go to bed with these hurricanes and the meteorologists are saying, oh, it might strengthen, it's a category 1 today, it might strengthen to a category 2 by tomorrow. And then you wake up the next day and suddenly it's a category 4. And that's not an exaggeration. That keeps happening multiple times. And so we know, we can prove now with the latest research that this is directly tied to warmer oceans. And heat itself kills. So heat is the #1 cause of death from natural disasters in the United States, way more than even hurricanes or tornadoes or earthquakes or anything like that. And we have examples of these heat waves. So for example, 2003 in Europe, when over 35,000 people died in that summer. And again, we now have, research which can prove that 70% of these deaths were caused by human-caused climate change. Human-caused climate change made this more likely to occur, and when it did occur, made it more intense, made it more impactful, made it more deadly. And this is just one example. In 2010, we had an even larger heat wave in Russia that killed over 55,000 people. Okay, heat kills. And heat melts ice. So I'm a polar scientist. I study glaciers in the ice sheets in Greenland and Antarctica, and I study glaciers around the world, including this one. I take Dartmouth students to the Athabasca Glacier every fall. And this is what the Athabasca Glacier looked like in 2017. And this is what the Athabasca Glacier looked like in 1917. And I've lined up these two images so you can just focus on the ice and see how the ice has changed, not just retreated up the valley, but also changed its thickness dramatically. It turns out that we've lost about 50% of the ice that you can see in this picture here in the last century. And we had an undergraduate student do a thesis to show that basically all of the ice that you can see in this picture will be gone by 2060. And this is not just this one glacier. This is not a cherry-picked example. Every region around the world that has glaciers are melting altogether, along with Antarctica, along with Greenland. And so as we look to the future, it's all about how much CO2 we continue to put into the atmosphere. It is a choice. If we continue to pump CO2 in at the rates we have been, a high CO2 scenario, we're looking at an additional 8 degrees of warming by the end of the century. If we dramatically curb our emissions, not just in this country, but globally, then we can reduce that significantly, maybe 4 degrees, maybe even less. And to give this a little bit more context, so here in Hanover, in a typical summer now, we see about 7 days where the temperatures are above 90 degrees. And 90 degrees is the level right around which humans start having health effects from the heat if they're outdoors. If we are under this 8-degree warming, that we're looking at more like 2 months, basically the whole month of July and August above 90 degrees here in Hanover, just by the end of the century. Versus lower emissions, we're still looking at somewhere on the order of 3.5 weeks. But you can see, depending on the choices we make, we can have a huge impact on the changes in temperature, and again, the health impacts on people. And I know that these may seem like small changes, right? 4 or 8 degrees. Let me tell you, as an earth scientist, 8 degrees is enormous. And to help explain this, I want you to understand that this is what New Hampshire coastline looked like the last time the earth was 8 degrees colder than today. This was the heart of the last ice age. The last ice age, on a global average basis, which is what we're talking about, was 8 degrees colder than today. And we had a mile of ice here on top of us in Hanover, and this is what the coast of New Hampshire looked like. And this is what the White Mountains would have looked like. 8 degrees is enormous. And again, the rate of change is unprecedented. We also know in terms of sea level, we're talking about feet of sea level rise into the future. The best estimate for New Hampshire under a high CO2 scenario is about 3 feet higher than today by the end of the century. But I want to point out this really large error bar here on the high side, all the way up to 7 or 8 feet under this high CO2 scenario, and explain where this comes from, because this is something that my own research is trying to understand better. And where this comes from is the fact that the last time the Earth was just 2 to 4 degrees warmer than normal. And I told you, we're already at 2. Okay, so the last time the Earth was 2 to 4 degrees warmer than normal, we know that global sea levels were 16 to 26 feet higher than today. So today you can see Florida here, and this is what Florida would have looked like the last time temperatures were just 2 to 4 degrees warmer. All of this area underwater with 16 to 26 feet higher sea level. And so we know that at those temperatures, Greenland and Antarctica are unstable. The melting that we're seeing today is exactly what we would expect. What we don't know, and the reason we have those error bars, is how fast those ice sheets will actually melt. Because again, we've never had this experiment before where we've warmed it so quickly. And we also don't know if there are special tipping points, points of no return, where once we cross them, it becomes very difficult or potentially impossible to prevent this future from happening. There is unfortunately some recent research suggesting that those tipping points are right around where we are now, or perhaps that we have even crossed them. I want to emphasize though that we do not yet know this. I do not consider this settled science, but we are concerned that these tipping points exist and that we're not far off from them. And so I think all the time about what are the implications of my CO2, not just affecting me or my children or even my grandchildren, but thinking out hundreds of years into the future when this sort of scenario will play out. And of course, we're talking there about Florida, but we know that other places do not have the same resources to deal with such dramatic changes in, say, sea level or temperature as we do. For example, in Vietnam, we see enormous areas, extremely well populated, densely populated, very close to sea level, where we estimate somewhere between 2 and 7 million people will be displaced by sea level rise just by 2050. Or take Bangladesh. You know, in the United States, we had Hurricane Katrina as sort of a monumental natural disaster. It was a Category 3 storm when it hit New Orleans. This is Bangladesh's Katrina, a Category 3 storm. We lost somewhere around 3,000 lives in Katrina. They lost 500,000 with a similar disaster. So we can see these effects are dramatically magnified in the developing world, where, of course, their CO2 input is minimal. They are not the ones who are responsible for these changes, and yet they are the ones who will experience far more of the brunt of the impacts. Because this is something we absolutely know, that those who are least responsible for causing climate change through CO2 emissions are the ones who are most severely affected. And this is true on every scale. This is true if we consider just the folks in the Upper Valley. This is true if we consider the folks just in this country. This is true if we consider the whole globe, every scale. So as a climate scientist, it is clear to me, we have this climate emergency that requires us to quickly decrease CO2. And this means that we need to fundamentally change our relationship with energy, right? Where do we get our energy to power our transportation, our cars, trucks, and planes? Where do we get the energy to power our electrical grid or our industry or heat our homes or power our businesses? And you know, these ratios change from place to place. Here's Vermont. But the bottom line is that this is all about our relationship with energy. And as much as this is a crisis, an environmental crisis, this is clearly also an enormous opportunity. We must change our relationship with energy. So we have this opportunity now to change it in a way that is more equitable and more just for everybody in society. And so that's what Shalanda is now going to talk to you about.
Thank you so much for teeing that up so nicely, Eric. Let me go ahead and share my screen as well. Okay. All right. So, the things that Eric outlined in his presentation really point to the need for an urgent intervention in this climate emergency. And sometimes that need for urgency is at odds with the need for justice and considerations of equity in this transition. And so today I want to talk a little bit about my work over the last 10 years and take us from the global, which I'll also address in my discussion, down to the local and state level. So on May 25th, 2020, a convenience store employee called the police. He reported that a man had tried to, or had actually purchased a pack of cigarettes using a counterfeit $20 bill. The police arrived on the scene and proceeded to publicly execute that man. That man was George Floyd. He was Black. He had asthma, and an autopsy report later revealed that he also had COVID. And so in many ways, George Floyd's life and his death are an embodiment of the unique violence perpetrated against brown and Black bodies in this country. And in a summer that was marked by protest and cries for Black lives and racial justice, we did not take to the streets to also march for a more just energy system. But I would argue today that the structural violence that is implicated in so many aspects of our society is also implicated within the energy system, and that the energy system itself is not immune from this broader reckoning with structural inequality and structural racism. And so today, I want to give a little bit of a prologue, which is to say, I want to talk about how I entered into this really interesting work called energy justice. And then I'll talk a little bit about what energy justice actually is and why it matters in this particular moment. And finally, I'll end with revolutionary power, a framework that I think is designed for this moment. It also happens to be the title of my forthcoming book, which will be out in just 2 days with Island Press. So 3 years ago, I was, well, actually, so it was the fall of 2016, time flies, 4 years ago. I was in Mexico City on a Fulbright fellowship, and my research was looking at the energy transition that Mexico is undertaking. I found myself in a conference room with other scholars, members of the national, the sort of NGO community, and other members of civil society. And we were there by invitation of the Mexican equivalent of the Department of Energy, the Secretary of Energy. And the Secretary had invited us all to the room to talk about how communities might share in the benefits of Mexico's energy transition. The only problem is they did not invite any members of the communities who were most affected by that country's transition. And as the Secretary started this meeting, a group of individuals from Oaxaca, Mexico, had come into the room to hold court. And they started by saying, "We were not invited to this meeting, but we came anyway." And so in that moment, these individuals who were indigenous, farmers, grandmothers, children, were saying, we need recognition in this transition, and we also need procedural justice, which is to say we need to have a say in how this energy transition is unfolding. So just to take a little bit of a step back, Oaxaca is a state in Mexico. It is the second poorest state in Mexico, which is itself a developing country, much like the countries that Eric previewed in his talk. It is also home to no fewer than 14 distinct indigenous groups that speak distinct indigenous languages and have distinct indigenous customs, and a place called the Isthmus of Tehuantepec, which is the highlighted area here, has been identified by NREL, the National Renewable Energy Lab, which is part of DOE, as one of the windiest places on Earth. It is also ground zero for Mexico's clean energy transition and transformation, in fact. Today, that place has the highest density of onshore wind of any other place in the world. And I began studying this place back in 2008 when I met indigenous peoples who were fighting against the broad, the sweeping wind development and infrastructure development that was happening in their territory. And what became apparent to me as I met individuals from this place called Oaxaca is that as long as we're relying on the same logics to drive our clean energy transition, we are doomed to replicate the inequality that is embedded in our fossil fuel system. And so in Oaxaca, there is widespread energy poverty, which is to say that people there don't lack routine and ordinary access to electricity. The cost of electricity is high for people who are living in the shadows of this technology. I also have learned throughout the course of my research that much of this development is happening without any sort of benefits flowing to the local community. And that is to say that even though there is this technology, even though there is this broad, widespread development happening in Oaxaca, none of the electricity is flowing into the homes. The electricity is serving large multinational companies like Walmart, like Cemex, which is owned or used to be owned by one of the wealthiest men in the world, Carlos Slim, as well as Coca-Cola and Heineken. So again, these are the same logics of development that drive fossil fuel that are being exported to the global south in the name of mitigating climate change, but it is absolutely exacerbating and creating inequality. So we might think that this sort of logic doesn't apply to the United States. And as Stephen said at the outset, I have had the opportunity to teach at the University of Hawaii. And so I landed in Hawaii in 2014, having studied Mexico's energy transition, having looked at indigenous rights. And when I got to Hawaii, I realized that Hawaii was beginning its own transition and beginning to do so in a way that could possibly and was very likely to exacerbate harm and replicate the inequalities and inequities that are embedded in the oil and gas based energy system there. So just a little word about Hawaii. It's amazing, and often on a cold New England day, I wonder why I left. But it is also a place where people pay among the highest costs for electricity in the country. Poverty is also high, in part because of the cost of living. And much of the energy development is fossil fuel based, and it is sited in indigenous communities as well as rural communities and communities of color. When I arrived in Hawaii, the Hawaii Public Utilities Commission issued what was called the Orders and Inclination, which actually for the energy policy wonks and nerds among us made sort of national headlines. The PUC said that the investor-owned utility in the state needed to figure out a way to make sure that more decentralized energy in the form of rooftop solar could get on the grid. And the utility was fighting back and saying, we can't get any more rooftop solar on. We need to go large scale. We need to go, centralized. And the regulators said, we think you can do better. There was also talk of a merger in the state where a Florida-based company, Florida Power and Light, came to Hawaii and said, we think we can help you figure out your clean energy transition. And they courted the IOU. Many in Hawaii were very nervous about this potential merger because Florida Power and Light had actually ended rooftop solar in Florida. And so its subsidiary, NextEra, is the one that came to Hawaii to try to court our IOU. And eventually that process concluded without the merger. And so that was seen as a victory for advocates on the ground. Hawaii also adopted a 100% renewable portfolio standard, which is an opportunity for the state to meet all of its energy needs using clean energy by the year 2045. And that was also adopted when I landed in Hawaii. Again, as I mentioned, the IOU there was saying that rooftop solar had hit its max and that there was no more room for distributed generation on the grid. And then finally, the state was grappling with community solar policy. And community solar is really seen as the sort of next generation of distributed energy generation and a way for folks who live in condos or who rent to participate in the clean energy transition. And so all of this was in the mix when I was in Hawaii. And unfortunately, during my conversations with policymakers and with other stakeholders in the Hawaii energy transition, I would ask, where do communities fit in? How can we ensure that Native communities, that the communities of color that currently house fossil fuel, how can we make sure that they are a part of this transition? And they would always look at me like I had 2 or 3 heads and say, this energy transition is purely technical. It's just about whether or not the lights go on. It's just about a fuel switch. And I understood the stakes of the state's energy transition to be much more, and to be very much about the social circumstances and the structural inequality that I was seeing all around me in the state. And so from Hawaii, I have learned a lot. So based on that experience, I started a program at the University of Hawaii called the Energy Justice Program at the law school. And I landed here in New England at Northeastern University in the fall of 2017. And I started something called the Initiative for Energy Justice. And the Initiative for Energy Justice is very much a response to this hyper-technical focus on the transition. And our team is comprised of lawyers who have been at the front lines of major energy transitions around the country. So my co-founder Subin was in California and Shiva Prakash was in New York, each states that were going through significant energy transitions. And what they noticed, like me, is that communities were often shut out of those transitions. And many of the people who were at the design table shaping energy policy simply didn't know anything about energy justice or equity. And if they did, they weren't sure how to put it into an energy policy framework. And so that has been the subject of my work. And so I want to drop us down into this moment in the last 15 minutes or so and talk about where we are, right? It's hard to have a conversation about racial justice without thinking about the events of the summer and without thinking about the events of last week. We are in a moment of incredible reckoning. And as I said at the outset, the energy system is not immune from this deeper reckoning with racial and social justice. We're in a long overdue reckoning with the energy system. We need to address the legacy of harm that is embedded in certain communities around our country. We need to look at the investor-owned utility model and really question whether that's the best way to get us to a clean energy future and one that is equitable. We need to address policies and laws that are trying to adopt ambitious clean energy goals and make sure that those have baked within them features that address social issues. We also need to look at energy burden, which I'll talk about a little bit later, and energy insecurity that disproportionately impacts certain members of our community. And then we need to think about how to broaden clean energy access, distributed local clean energy access for those who need it the most. And so again, where are we? What is this moment? We are in the middle of an historic pandemic that has had disproportionate impacts on Black and Brown people in this country. So this is a slide from an article that was published way back in July by the New York Times, showing that Black and Latinx folks are 2 to 3 more times likely to be infected and 2 to 3 more times likely to die as a result of COVID-19. We also saw a study come out in April, published through the Harvard Chan School. This was actually a working paper at that time, published through the Harvard Chan School of Public Health, showing that just a small exposure to air pollution actually led to a large increase in death rates. And so who are the people that are more vulnerable to death rates related to COVID-19? Latinx and Black people in this country. Those in the environmental justice community have long recognized that Black and Brown people are simply absorbing more toxins. They're more likely to live in the shadows of fossil fuel generation than their white counterparts. And so this feeds directly into the harms that they're experiencing as a result of this pandemic. We also know that, Black and Brown people are wildly outstripping their share of the population in terms of deaths and caseload. So this is a moment not only of racial reckoning with respect to the criminal justice system, but racial reckoning with respect to so many aspects of our system. And again, I would argue that the energy system itself has a race problem. And so I want to share a little bit about some of my work here in the Boston area. Of course, I had seen all of these trends nationally, looking at sort of environmental justice implications in COVID, and I really wanted to understand what's going on in my own backyard. And this is a slide of the Boston metro area that confirms that the caseload rates are more prevalent in communities of color. And so I've circled a couple of communities for those of you not from the Boston area, Dorchester, Mattapan, Rosendale, and Hyde Park, which are predominantly Black and Brown communities. And you can see just above that, we have Revere, Everett, Chelsea, which are also communities of color. And Chelsea at one point in the summer had the highest caseload and infection rates in the entire country during the summer. And so when we think about air quality and exposure to pollutants, these are the same communities that have high concentrations of air pollution. So Dorchester, Mattapan, Roxbury are circled here. And you can again see that Chelsea and Everett have high concentrations of air pollution. And so what this means is that these are environmental justice communities, right? And these are environmental justice communities that are also being impacted by COVID-19, which means that they are bearing the brunt of this pandemic in the same ways that they've borne the brunt of the organization of our transportation sector and our energy sector. And this is not accidental. The organization and structure of these communities is very much a product of deliberate choices made through environmental and energy policy. And so again, when we put these slides side by side, we see, again, the same communities of color on the left are also environmental justice communities, which is indicated on the right. And so in effect, these communities can't breathe, and they haven't been able to breathe for the past several decades. And this is a direct link between, again, COVID, racial justice, and this particular moment, as well as the organization of our energy system. And so the image on the right is actually not from Boston. It's from a place called Port Arthur, Texas, which is the birthplace of the modern fossil fuel industry, as well as the current home to infrastructure, vast infrastructure in the Gulf South. It's also the place where my father's family grew up. And for folks in that community, so this is a predominantly Black and Latinx community, low income community. For folks in that community, the idea of sheltering in place was familiar even before COVID. So often, because they are in the heart of the petrochemical and fossil fuel industry, they were asked to, or ordered to shelter in place, to cover their windows with plastic and with blankets, because the air quality was simply too bad. So again, these are deliberate choices that we've made regarding our energy system, and we have a real opportunity to change this narrative in our clean energy transition. Unfortunately, the energy transition in the United States is very much proceeding without having equity at the heart. And so I wanted to understand how these environmental justice communities, how these COVID impacted communities we're experiencing our clean energy transition. And so here is a reflection of data that we have from the Massachusetts Clean Energy Center, which shows just where solar has been adopted in communities in the Boston area. And so we have a blow up of the communities that I circled on prior slides, Roxbury, Dorchester, Mattapan, Rosendale, and we see that there is very little solar in certain communities. And I really wanted to understand this large circle on the bottom left corner of the left slide, or the left image. And Mattapan has a lot of solar in about 2 blocks. And so that's making this look like it has a ton, but it's really not. And then when we compare that to more affluent, wider communities, Wellesley, Needham, Newton, West Roxbury, there just is an extraordinary amount of solar access. And solar isn't going to solve all the problems, but it will displace and offset fossil fuel generation, particularly peaker plants that are located around the state. And so not only is solar not widely available in communities of color in the Boston metro area, but even when communities do have access to solar, they're less likely to have solar that they own. And so many of you out there in cyberspace may own your own panels, and you realize the economic benefits that come from owning your own panels. What we found in doing this research is that people in communities of color are more likely to have solar that is third-party owned. And so I'm currently working on a project that is really digging into what that really looks like. But suffice it to say that this clean energy transition as it is unfolding is deeply inequitable, and we're really missing an opportunity for deeper economic justice. And to echo the words of a young woman who was on camera this summer in the wake of riots relating to George Floyd's murder, communities of color simply don't own anything. And we are proceeding with this transition in a way that replicates that lack of ownership with respect to solar. And so I want to pivot now in the last 7 minutes or so, 5 to 7 minutes, to energy burden and energy insecurity. So energy burden is the overall amount that a household is paying to meet its energy needs. The lower your income, the more of your overall income you're spending on energy needs. Due to the structure of our rate design in this country, or at the state level, essentially. Energy insecurity means you lack reliable access to uninterrupted energy sources at an affordable price. And so a study done by the Energy Information Association revealed that about a third of Americans have experienced some sort of energy insecurity. And that's pretty striking, I think, in a country like ours. It should come as no surprise at this point in my presentation that energy insecurity is more likely to be felt if you're a Black or Latinx person in this country, or a Native person. So over half of Black people in this country experience some energy insecurity, and over 61% of Native and American Indian folks are experiencing some sort of energy insecurity. So this is stunning as I see it. And so with this pandemic, we have seen economic distress across social strata, and particularly felt in communities of color. And so as a result of the public health emergency of the summer and spring, states and utility commissions all over the country adopted bans on shutting people off from their electricity during a time when we were asked to shelter in place. And we saw not widespread adoption of those moratoria on utility shutoffs, but certainly quite a few states had decided to do that. In some cases, they voluntarily, either the executive or the PUC, the regulator in the state, allowed for a voluntary adoption of a moratoria on utility shutoffs. But unfortunately, in the months since then and in the fall, we saw the expiration of many of those moratoria, and our research team at the Initiative for Energy Justice has been tracking that. So we had 36 enacted moratoria on utility shutoffs, and this is electricity, water and energy, gas. But 26 of those have expired, and some of those have winter protections, but not all. And so people are now beginning to be disconnected from electricity during the height of the pandemic and during the winter months. And so what COVID-19 has really exposed for us are the twin burdens, unequal benefits, and structural violence that people are routinely experiencing as a result of the energy system. And this is very much racialized. Energy burdens are borne by BIPOC communities, so that is to say Black, Indigenous, people of color. And economic burdens are also disproportionately borne by these communities. They're paying more, they have a higher energy burden, they're more likely to experience energy insecurity. And the benefits of this transition have not been equitably shared. And so energy justice allows a way out of this. Energy justice is a framework. We have an energy justice workbook for any of those of you out there interested in checking that out. But energy justice is a way for us to get past this and get out of this this situation where we're experiencing such structural inequality. It refers to the goal of achieving equity in both the social and economic participation in the energy system, while also remediating social, economic, and health burdens on those historically harmed by the energy system. And these are the frontline communities that Erich so eloquently spoke of in his presentation. There are several aspects of energy justice. I've circled them on the left here: distributional justice, procedural justice. That is, what the people in Oaxaca were fighting for. Recognition justice, that's what they were fighting for. Distributional or distributive justice is having a fair share of the benefits of the energy system. And at the bottom here, we see an arrow called restorative justice. And I really see that as the healing that is possible through the energy system. And so I go a little bit further than my colleagues who developed that framework in the UK. And I say that not only do we need all of those types of justice, but we need to center frontline voices in policy making. Energy justice should also be, or also requires that we take an anti-racist, anti-oppression, and transformative approach to crafting energy policy. Vulnerability is central to my analysis, and that is along racial and social axes. And energy justice is praxis. So what that means is that we must practice energy justice on the ground and through the lived experiences of those who are most impacted by climate change and most impacted by our existing energy system. And so revolutionary power, as Steve teed up, is the notion that the technical terrain of energy policy should be the next domain to advance civil rights. We need to recognize prior harms. We need to embed equity in clean energy goals. We need to include the voices of frontline communities in energy policymaking. We need to adopt solar policies and incentives that center BIPOC and disadvantaged communities and target them for ownership opportunities. So that's a step beyond what we normally see in the climate discourse. And then we need to reduce energy burden for disadvantaged communities. And so in short, we really need an energy system that stops killing us, right? And that is the central conceit of my work. And so I've written a book about all of this. It's called Revolutionary Power. I urge you to take a look. And I really just appreciate your attention today. Thank you so much.
Thanks very much, Shalanda and Eric. Great talks from both of you and a nice compliment. What we'll do now is we have about 13 minutes for questions and answers. So I'm going to get things kicked off. I'll pull them off the Q&A, and anybody who wants to ask a question, please just put them in the Q&A and I'll try to pick them up and we'll take them from there. First, just on a technical area, Eric, that somebody noted that you see these sharp rises, sharp being 6,000 years or something, in CO2 record geologically, and then a much slower decline. Do you have any sense of what the underlying reason for that asymmetry is?
Yeah, it's a great question. So, fundamentally, what is pacing when we have these ice ages every 100,000 years? And what is responsible for what you notice, this sort of slow decline of cooling over time when it's warm? Is, I talked about the strength of the sun, but we also have Earth's orbit around the sun. And so it's actually tiny changes in Earth's orbit, which are completely predictable. We totally understand these. And they take tens of thousands of years. The fastest of these orbital cycles has a period of 22,000 years. So these are very, very slow changes. But what's interesting about them is that despite these slow changes that are forcing it, you can see these really abrupt changes in the climate. And so what this tells us is, again, it's a warning that we do have these thresholds in the climate system. We do have these tipping points where even a slow forcing can invoke rapid change. And now with our human CO2, we have a rapid forcing, right? And so that's why we still have some uncertainty about where we're headed even in this coming century. And, not to make too strong a point on this, but this is another reason why without human CO2, the climate should actually be slowly cooling, is that Earth's orbit. So it's a great question.
Great, thanks very much. Shalanda, here's one for you. I think there's this question about how do policies for solar, but also energy efficiency and other energy policies incorporate justice angles, and how could they do it better?
Oh, so great. Hi, Elizabeth. Good to see you in the audience, even though I can't see your face. So I think right now we're not seeing enough or seeing policies go far enough with respect to solar access. So in Massachusetts, we actually have a really great credit vehicle called the Mass Solar Loan Program, which is really designed to prioritize low to moderate income households. But unfortunately, that program has not made its way into communities of color. And, I think what I like to say, and I will get to the main crux of your question, but what I like to say is if we're just erecting the infrastructure, meaning the mechanisms, the financing models of the clean energy transition on top of our existing fossil fuel system and on top of a structurally inadequate economic system, then we're bound to replicate the inequalities of those systems. So we have to think of new models. And so for whatever reason, the mass solar loan program is not working, but I would suspect it's not working because of historical lack of access to finance in communities of color. It's not working because we have predominantly white solar companies going into communities, and they're going to go in communities that are low-hanging fruit for them, right? So we need to rethink the financing models. We need to rethink kind of how we the businesses that are engaged in this and create businesses that are owned and operated by people of color and populated by people of color. So even if policies are well situated and beautifully designed, the implementation can be a challenge if they're being implemented in a structurally unequal society. I think energy efficiency is fabulous. We often have sort of the sort of conflicting incentives problem where landlords are not willing or not able or don't care about making their homes more efficient because they know that that is only going to benefit their tenants. So we need to think about how to draft policies in a way that really incentivizes landlords or requires them, if they want to have their housing stock on the market, to have efficient homes. And so that's a policy move, I think, that could be really could be powerful. And we need to make sure that those economic benefits do flow to the renters. I have also begun to argue for a cap on energy burden, which would mean that we structure our rates to cap energy burden at about 2 to 3%, maybe up to 6%, which is kind of the absolute max. And ensure that everyone has to pay 6%, which would resolve the problem of recouping. It's an economic question. I'm not an economist, but I'd love to see the modeling on that. But it would mean that the wealthier folks who actually use more energy are paying their share. And people of color and poor people are no longer kind of shouldered with this outsized energy burden. And that would be a radical intervention, but New York is experimenting with that, as well as California. California is thinking about capping energy burden. So, these are things that policy can do to really move the needle on the justice front.
Thanks, Shalanda. I want to ask a question that I think both Erich and Shalanda can address, and it's really sort of bringing together a number of the questions in the Q&A here. And I think it comes down to the following, which is Erich has painted a picture based on facts saying the Earth is undergoing a rapid change and a change that's never been seen before because of the forcing mechanism CO2 emissions arising from our historic energy systems. So that's a challenge and that's a problem. At the same time, I think, Shalanda, what you're arguing is if we're going to need to make this transition anyway, how do we do it in a way that is more socially just and equitable? And I think what's in these questions here is there could be a tension there about moving quickly and also being just. And I would say even further that you, Shalanda, I think in part are arguing that that many of the inequities that you describe are not just based on energy, but there are many other forms that drive it, including racism, access to good education, et cetera, et cetera. And so what do we do about linking energy and energy justice to moving quickly to address the climate change challenge? And it'd be great to hear from both of you on this topic. I suspect it will eat up the remainder of our time, but it's a really interesting question.
Yeah, Erich, do you want to give it a shot first, or go ahead.
I'll let you take a first stab here, Shalanda.
Okay, great. Well, this is the central focus of my work, and this is the tension that was identified in Mexico, the tension that was identified in Hawaii, where a lot of the green advocates that I encountered either kind of got the equity stuff and they were just like, please don't mention equity right now, because all we want is to have more clean energy on the grid, and then we promise we'll deal with the equity piece later. Or they were simply, really unwilling to hear anything about equity. And so my argument is that if we proceed with this energy transition in a way that does not center and does not focus on equity, then we will be in a world of hurt after the fact, right? We're still going to see resilience issues in communities of color, right? If we're not thinking about how to make sure they have backup power, how to make sure, they're able to bounce back from storms, et cetera, in terms of, the adaptation piece and making an energy system that is responsive to issues of resilience, then they're going to end up, migrating. I mean, it's just like there's so many ways in which our fates are bound up. I mean, there is a very strong moral argument that, I'd love to just relax on that and sort of lean back and say, well, we have so burdened them over the last 100 years with, an inequitable energy system that now we owe them something. But I think there's a real sort of economic argument and a political argument to make around making sure that our most vulnerable are not rendered more vulnerable in this energy transition, and that we should in fact target them for opportunities. And I'll give you an example of this. I mean, this is in California. So Eric showed some really devastating slides of the fires all over the world. And the one with the kangaroo gets me every time. I'm just like, it's so horrible. But in California, I mean, we had a record wildfire season, and we have no idea. My team has been trying to understand who has been preemptively shut off from power due to the utilities, again, the investor-owned utility, PG&E mainly, its efforts to prevent any wildfires caused by its own equipment. So PG&E has been a notoriously bad actor. Its equipment has been the cause of wildfires in the past. And the most infuriating part of that is that ratepayers are paying the utility to maintain its infrastructure. But the utility has sort of taken a shortcut and said, we're not going to maintain all of these thousands of miles of infrastructure. We'd rather give our shareholders returns. So that's a whole different story. But this is structural, right? This is about the energy system. And so we've been trying to understand who's been impacted by these preemptive shutoffs of power. And unfortunately, the regulator in California has not required any of the utilities to report at a granular level who has been impacted. So we don't know who is medically vulnerable, who's had a power shutoff, who is an environmental justice person or low-income person who's had a power shutoff. And so these are energy justice issues, right? That transparency piece. Creating policies that bring microgrids to those communities, that bring rooftop solar. I mean, this is where climate and energy interface. And again, if we're not focused on that, then it's going to create a lot of problems for the society down the road. So just a snapshot.
Yeah, I just would say too, what I hoped to convey is that from a climate science standpoint anyway, I think we have zero doubt now about the imperative, both an environmental imperative and a moral imperative, to act swiftly to reduce CO2, which requires a fundamental change to our energy system. And Stephen, to your question, I guess I would challenge the fundamental assumption that there's a battle there, right? I mean, do white affluent Americans not get solar power on their rooftops if we are creating a system that is more equitable and just for all communities? I don't necessarily see that, right? I think in many situations here, this conversation has not been had. I mean, I'll tell you from my personal perspective, I've been thinking about climate change since I was in the 6th grade, right? It was my 6th grade research project, but it has only been in the last couple of years that I have really been thinking about this, the required transformation in a way that's beyond just CO2 tons that need to be removed, but thinking about it from a societal level and thinking about it with this just and equitable lens. So we need to be having these conversations. I don't think it's one or the other. It clearly has to be both. And so I think this is a great way to start off thinking about these things is seminars like today.
Yes, no, great. Thanks, both of you. I think this is a great way to end this because I think it's bringing those things together that will be really interesting. How do we do policy? How do we do the implementation? How do we think about the opportunities that it creates for us as a world and a society, as opposed to thinking about it from a negative point of view? We are very we like to keep the time. We like to give people, have good Zoom hygiene. So we're going to sign off here in just a moment. I think, Stephanie, you're going to just announce what's coming down the pike. But as we're doing that, I just wanted to thank you both, Erich and Shalanda, for a great kickoff for this term and a wonderful way to bring science and society and energy all together in the same discussion. Thank you so much. So I guess what you'll see up here is our upcoming series. So we've got some early career researchers on the 20th, where you have our next seminar series with Julio Friedman on the 26th. And then please join us on February 3rd for new energy conversations with early career researchers. Again, Dr. Sarah Jordan of Johns Hopkins University. So these are ongoing seminars that we have. Please join us. And I'm glad we had a great turnout today. It was roughly 100 people for the entire time. That's one of our records. Thanks again, Shalanda. Thanks again, Erich. And we'll talk to you soon. Bye-bye.
Thanks so much, Steve.
Yeah, thanks a lot. That was great.
Bye, folks.
Bye. Have a great day.